Hey everybody, it's December 27, 2018. It's probably going to be my last video of the year. Lilith is creeping around here, so she might bump the family. She's going to do it right now, maybe. Anyway, what is today's topic? Somebody asked me an interesting question. To me, it seems like the question was kind of like, why are you asking that? But if someone doesn't understand basic math, I can see that. I can see why they asked this, and it's actually a reasonable question. Their inquisition was basically this. If units cancel in a math problem, why do we even bother them? Why are they even included if they get eliminated? And the answer is this: because it's part of the process of working the problem, just like balancing an equation, okay? Or adding, or subtracting, dividing, working with exponents, fractions. It's just a part of the process. And if you don't include those units that cancel, you're not going to get the desired answer. Because math is a process, all right? That's all it really is. And, working with exponents is the same, addition is the same, PMOS is the same. All those things are the same regardless of the units and quantities. You work it the same way, which is something you can't say about language, which is actually going to affect something here I write on the board. But I am going to show to you why you still need units, and I'm going to use money. Because the dollar seems to be something people get like that. When I used to tutor math in college, I would do story problems with like tons of rocks being moved or something like that. And people would just look at me like a deer in headlights. But I would take the exact same problem, just instead of rocks, I would do dollars and I change the values a tiny bit, and they get it like that. Because you do this kind of stuff every day in your head, you just don't realize it because you're not writing it out. And you're usually working with your variables already on one side of the equation, so you don't have to balance anything. And that's what I'm going to show you here. So here's our units. There's our $2 per pound. Now, this is the way you would see it written. And you see this, and what this is actually telling you is that this is a division problem. All right? That's division, right there, okay? So I can write it like this. Well, where's the dollar sign? It's actually over here. Why is it over there? Well, because our math is kind of reflective of how we talk. Like we say $2 per pound. We don't say pound per $2. So it goes at the end. So units always go after the quantity. Here's your quantity, here's your unit, okay? So I even say $2. I don't say $1.02 per pound. So if anyone knows why we do this instead of this, I would actually like to know. And pound is Latin for something I don't remember. But I just sat there and said, well, our units go after our quantity. Well, what's my quantity here? Well, my quantity here is 1. We just don't write it. It's implied. Like say it out. Like you would $2 per single pound. For 1 pound, it costs $2. So the 1 is there. And it's not a 0 because anything times 0 is 0, and you have a 0 in the denominator. Okay, so now we have this. We have the start of our problem. Well, that's nice, Steve. Where's the rest of it? Well, say I want 5 pounds. We don't put the S at the end of pounds. Actually, technically that's incorrect because there's no S in Latin for plurals. So that's how it's written. And I'm using pounds because it's something Americans are familiar with, and Americans tend to be bad at math. I'm sorry, but it's the truth. So I want 5 pounds. Now you look at this and you might be like, $2 per pound, I want 5 pounds, oh, I'm gonna need $10. So you already did it in your head. You just did an algebra problem, canceling units in your head, multiplying, and coming up with the unknown. You did it all in your head. It's just, I'm showing you the details of the process involved in this, and we'll get to that in a minute, all right? But yes, it would cost me $10 for 5 pounds. I want to know something. I know I have $2. Cost is $2 per pound, and I need 5 pounds. That equals my unknown, my variable. This is still an algebra equation. It's just everything is already, you don't need to balance the equation because your variable is the only thing on the other side of the x, okay? But how do we figure this out? Well, we could sit here and write $2 plus $2 plus $2 plus $2 plus $2 equals $10, okay? But the problem with that is that's annoying, especially if this was, say, 50, or this was, say, $1.37 instead of $2. It can get to be annoying, but there's a faster way to add, okay? We call it multiplication. And that's all multiplication is it's a faster way of adding. Subtraction is adding the opposite, and division is doing fast subtraction. So if I were to figure this out properly, and sometimes people who have had enough math know that instead of a multiplication you can put in parentheses or a dot, but I'm just going to use the x because that's what everyone's familiar with, or the multiplication sign, technically that's an x. But anyway, so how would I figure this out? Well, this is still a fraction, 5 pounds, I have a 1 here. It's implied, okay? I want 5 pounds, so I have a 1. Okay, does anything cancel? Now here's where we get into the canceling. Yes, something cancels. My pounds cancel, because when you're doing multiplication, this cancels this way, okay? So basically, now what do I have? We're going to divide that 1 back into 5, because 5 divided by 5 is, or 5 divided by 1 is 5. I just wanted to show you there was a 1 there. And this is what we're left with, okay? Which equals 10. 10 what? $10, that's the only unit we have left. I'm just going to put it there for consistency. So even though our pounds canceled, without that cancellation, I couldn't work this problem, all right? Because if I just had 2 times 5, that just gives me a quantity, or $2 times, or that's what I have, right? Sorry, if I just said 2 times 5, that just gives me a quantity of 10. It doesn't tell me what it is. So even though these canceled, they were still key to figuring out this math problem. Because actually without them, I wouldn't have any of it, okay? So just because units cancel doesn't mean they're irrelevant to figuring out the problem, all right? They're still important. We're going to drop the money and I'm going to show you how the same thing works, how the process is still the same. 10 meters per second, okay? As you can see, we have a division problem like we did before. So I can write it. I'm going to do the exact same thing. I'm just using meters and time, distance and time, as opposed to money and pound and weight. Well, pounds, mass technically. But anyway, so I have my 10 meters per second, okay? And say I want to know how long, how far, how many meters I can travel in a set amount of seconds, all right? So we'll just say 60 seconds. Okay, so I want to know how many meters I can travel in 60 seconds at 10 meters per second, okay? So, once again, I have an unknown. Let's use z this time. Okay? Same thing as before. There's a 1 implied here. There's a 1 implied here. Okay? But, we don't need to write them. But I will here just because I'm canceling units. And how do I know there's a 1 here? Obviously, 60 divided by 1 is 60. So there is a 1 there. Do the same thing as before. And you may already have figured it out, but I'm just showing how this works regardless of your quantities and your units. It's a process. So we know that we're going to multiply. And since we are multiplying, our seconds, since they're crossing one another, will cancel. There's nothing here to cancel. So that stays. So we have 10, essentially 10 meters times 60, which is 600 meters. That's how far we can travel in 60 seconds it's just an example, okay? I just wanted to show you this with different units and different quantities, but the process is still the same. Okay, so if you like this kind of content, and I'm not really big into producing hardcore, elaborate videos, that's just not what I do. The educational part's more important to me, but not everything on my channel is educational. Now, most of it is science, see, and when I say science, it pertains usually to geology or physics in some way. There is some math, which is tied into this and this, which I'll get to in a second. There's cats, lots of cats. My avatar is a cat, so, you know, I have a lot of them. Construction, me and Sarah tend to build things at random, like randomly a big shed outside in 2017, and still standing surprisingly. Outdoor, what's that? Well, that's hiking, field geology, and amateur astronomical observations, which ties back into this. And so does the geology, ties back into this times 2. So this is basically what my channel is about. So if you would like to see me keep doing videos, please like and sub, because actually I do this because I like it. I don't have a ton of subscribers. My videos typically get 100 views at the, you know, somewhere between 100 and 200. I have one that has 15,000, but you know, I rarely hit 500. I don't do this for the monetization. I don't do it for the popularity. I do it because I like to do it. And you liking and subbing shows me that you like this as well and that you would like to see more. It keeps me motivated. But anyway, that's it. And I hope you learned something.